Good morning, good afternoon, everyone, wherever you're calling in from around the world. Welcome to our webinar. I'm Thomas Neeson, I'm Managing Partner at Cundall, and I'm really pleased to invite you to this, which is the first of our second wave of webinars on delivering low carbon, sustainable futures for everything that we do. Today's seminar is entitled Delivering Net Zero Carbon, and probably the first question I'll have for the panelists is to explain what net zero carbon is, and I'll let Alan, one of the speakers, start off with that because it's certainly a topic of some confusion for many in the industry. We obviously meet in really challenging times, more so in some parts of the world than others. If you notice on the bottom right of our screen here, Madlen is in our Cundall office in Perth, and Perth have returned to working as normal, and Madlen can explain how many people you can get in restaurants and beaches and everything in Perth if you can manage to get yourself there. At Cundall, sustainability is at the core of everything that we do. Today's webinar is just one in a series that we're publishing and are making available on YouTube for everyone to demonstrate and to deliver on our sustainability roadmap, which is based on 4 cornerstones of things that we can impact on and affect, which are our projects, our homes and our communities, our workplaces, and then providing industry leadership. And we're hoping to do some of that today so that we can join you in a debate and a discussion and learn from each other on the things that we can do to deliver better projects going forward. Today's seminar is about 30 minutes long of speaking. The team have put together a lot of information, so please feel free to list your questions in the Q&A box as we go along. I'm sure the speakers will remind you of that, and we'll sweep up the questions at the end. If we run out of time in the Q&A, we will answer your questions by email. And it's not just a one-way flow of information. We're keen to learn from everyone on the call, so please help us by raising your points as we go through. A quick introduction to today's speakers. I've got Alan Fogarty. They're a panel of international speakers, all with international experience, having worked across the globe, and that's really beneficial to us as a business because of the experiences they can all bring and join together for the benefit of all projects we do. Alan, who had his hand up, heads up our sustainability team in the UK, and he specialises in low energy and sustainable build and design. He's got many years of experience in this that he's happy to share. Qian, who's in the centre of the screen, is our specialist on life cycle assessment of materials and carbon, and he'll expand on what we're able to do in this field and where some current industry and future industry thinking is going in this. He's got a lot of experience as a specialist consultant in the field, working with a lot of developers and also been part of the writing the whole life carbon assessment guidance for the new London plan, which will be central to all development, certainly in London for the period going forward, as we try to make a real difference in this. Madlen, as said, is based in Perth in Australia and has worked in Europe and Australia. She specialises in corporate sustainability advice and particularly on climate change mitigation and adaptation. And Madlen was responsible for our whole Australian business of Cundall Australia achieving carbon neutral certification in the last year, and is helping with our project to make all of Cundall globally carbon neutral in the current year. Without any further ado, then I'll hand you over to our speakers. Please raise your questions as we go along, and we can have a discussion at the end to pick up everything that we've covered. So thank you, and over to Alan.
Thanks, Thomas. Good day to you all, and thank you for joining us. I'm going to give you a brief introduction to Cundall, and then set the scene with net zero carbon before we get into the main section itself. So if I can control the screen, there we go. So in Cundall, we've been going since 1976. We are a multidisciplinary engineering organisation with 25 offices around the world. We are a one planet company, which means we practice what we preach in terms of sustainability, and we're looking to be carbon zero by 2020 which Madlen will talk a little bit about in terms of the methodology. This is showing where we are around the world. So in Australia, Singapore, Shanghai, Hong Kong, Middle East, in Qatar and Dubai, in Europe, in Spain, Romania, and Warsaw, and right around the UK, Northern Ireland, and Southern Ireland. And we practice what we preach. So we're a one planet company. Zero carbon is one of the key areas that we have focused on, but there's a whole range of other areas there too in terms of climate change adaptation, health and well-being, and so on. But today it's zero carbon that we're focusing on. And it's about people and planet. You have to look after both, and it's trying to find that integrated approach, be it looking at the environment externally or environment internal to a building. So in terms of talking about net zero carbon buildings, certainly the World Green Building Council and local green building councils have been looking at this, and the general approach seems to be the new buildings need to be zero carbon by 2030, existing buildings by 2050. But what do we mean by net zero? We're going to use energy in buildings simply because without energy, we don't have a functional operational building. But the whole objective of net zero means that you bring the energy consumption down to the lowest possible, and in order that the renewable energy generation that is growing and where the two meet is effectively where we can achieve zero carbon. So we will still be consuming energy, but that energy will be provided by renewable energy. And it's not just about operational energy. So we have to think about the energy that goes into the construction of the building, then looking at the operation as well in combination. But then there's a whole range of things in terms of maintenance, demolition, and reuse of materials at the end of the life. So net zero whole life is really the end goal for all of this. We had set out in previous presentations the steps to achieving net zero carbon, which I won't go through in any great detail, but just to highlight them, it's about passive building design, which I'll talk about today, reducing operational energy demand consumption, reducing or eliminating fossil fuel, looking at renewables, limiting the upfront carbon emissions, considering whole life issues, which is carbon and cost, which I'll touch on, and then looking at offsetting and public disclosure. So passive design is where I'm going to focus mostly on today, and I will touch on the concept of whole life cycle costing as well. Qian's going to focus on limiting upfront embodied carbon, and Madlen will focus on the offsetting and public disclosure. What's confusing many people is basically the targets are set as a number. So this table shows the kind of trajectory. So we're at about 200 kilowatt hours for typically an office building. And by 2035, the idea being that we get down to something in the region of 70. The point is 70 doesn't really tell us an awful lot about a building. What does it actually mean to the design of it? So that's really what we want to look at today to make sure that people have an appreciation of what's involved. And getting to zero carbon, there's no silver bullet. It's about a series of incremental changes that will get us to the point where we are very, very low, which means we have to put a lot of effort into all aspects of building design. A key point is about looking at real energy in buildings. And we in the UK, we certainly haven't done that particularly well. Australia has with the Neighbour scheme, which is going since 2020, and it's demonstrated an ability to reduce actual energy consumption by about 70% in buildings, which is phenomenal. And the design for performance is the equivalent to Neighbours here in the UK, primarily for office buildings. But it's not just office buildings, it's all kinds. So Welsh Government, we've been working with them on their specifications as to how they can embed this process into their designs, the idea being that you're looking at predicting real energy consumption and then seeing what happens in the buildings upon construction and making sure the two match. And that's a really key point about delivering quality and low energy buildings. If we design the same way as before, we will get the same buildings, and that's stating the obvious. So we have to do things differently. And design optimization is something that we've always talked about, but actually we don't do it particularly well. And we really need to think about this properly. And preconceived ideas need to be left behind. So one of the things we always see with buildings is the discussion of orientation at the start. And we generally don't have the choice of orientation. We do have a choice of what goes onto the facades themselves. And typically people will say horizontal shades on a southern facade and vertical shades on an east and west facade. So just briefly looking at that, we can see here that a horizontal shade is very effective on a southern facade. If you put the same horizontal shade on a west facade, it is not nearly as effective. If you double that up, then you're getting something that's quite useful. And if you look at the equivalent area with a vertical shading system, at peak time for an air-conditioned building, it does little or nothing in terms of protection for it. So preconceived ideas in terms of shading and orientation, we really do need to think about. Another example is looking at naturally ventilated buildings. And again, if you look at various orientations, on an east facade, the sun rises at 4 o'clock in the morning, but people don't occupy the building till 8:30. And by 10 o'clock, the sun's off that facade. It's onto the southern facade. It'll stay there till 2 o'clock. And then it'll stay there till late evening. But generally, some buildings such as schools, the kids go home at 3:30. So there's only an hour and a half of exposure morning and evening time for that particular type of building. And you could look at other ways of keeping the sun off those facades through planting, possibly surrounding buildings or providing protection, etc. So looking at a naturally ventilated building where the criteria is risk of overheating, there's far greater risk on a southern facade than there is on an east or west. And equally, there's far less risk of glare on an east and west facade than a southern facade. So the ability to keep blinds up, maintain views to outside, and good access to daylighting is greater on those facades. So we need to think about these issues more carefully. And we see so many commercial buildings as glass towers, and they have too much glass, they have too much light, so the blinds are down, which means you have poor daylighting. You've got too much solar gain, which means you have too much cooling load, and you've got too much embodied energy, which Qian will come on to. And there's ways around this. You can have closed cavity facades, which are very effective, and we've done these before, to keep the solar gain out while allowing lots of daylighting into the space. But equally, they do have very high embodied energy, and that's a reason for avoiding using this particular approach. So how do you define how much glass you should have in a building? Well, primarily it's there to give you good access for daylighting, and we shouldn't be using things like daylight factor to assess daylighting in buildings. We need something that's far more realistic, and we should be using something like a useful daylight index. So a useful daylight index tells you what is useful to you in the building. So if you've got too much light coming in, then you effectively will close your blinds, you lose access to your daylighting, and you lose your views to outside. And if you've got too little, then you need to have artificial lights on. So that's how the useful daylight index actually works. And you can do other things to improve your daylighting levels in spaces. So you can reflect light from the perimeter using light shelves. Or here's an image from our office in London where we have this very light material on the ground. It's a recycled plastic, which is easy to clean, which is why we went for the light color. But the result is it bounces lots of daylight into the space, which feels great, but actually it's just improving the light right across the office itself. And this is not a new concept. We've been doing this in schools in the UK since 2013, and we've seen the changes that have happened. So the floor to ceiling height has typically increased from 2.7 up to 3.3, and we know taller spaces are better for daylighting. That's not new. There's no downstand beams along the perimeter because you have to get the window head right to the top of the soffit, because the top bit of glass is what brings the light furthest into the space. And equally, the areas of glass have fallen to 30 to 35% as viewed from the inside. So this stops huge amount of lights accumulating around the perimeter of the building itself, which means your blinds have to come down. It also has the additional benefit that it keeps the solar gain out. And we've been using heavy-duty Venetian blinds to bounce the light to the back of the spaces themselves. And this has proved to be very effective. So what does this mean for potentially other buildings? So if you take a commercial building, you would typically have quite a lot of glass on it. And what we would be looking to do would be try to increase the floor height, which is difficult because of cost issues. It may well be that the planners might agree to taller buildings to compensate for the fact that you're making them more sustainable by getting better daylighting. You'll see less glass, but taller windows to get the light as far back into the space as possible. Another possible combination of that might be rectangular, so you've got more area at the top, so you get more light to the back of the space, and very narrow at the bottom so that you are controlling the solar gain along the perimeter. And this is not limiting architecture at all. Here's a typical type of building which has already got some of these ideas in it. It's just using the creativity of architects to take some of these rules and make them work effectively. And we need to think about how we behave in buildings themselves too. And a temperature of 22 degrees does not define comfort, because some people will be comfortable with that temperature, others won't. And if we allow temperatures to fluctuate within a building, then we're putting in less energy. So that might be less heating energy or less cooling energy. So in case of cooling, if we said we won't cool a building till it hits 30 degrees, then we save a huge amount of energy. Now, why 30 degrees? Well, our Doha office or our Melbourne office does not turn on the cooling till it hits 30. But there's lots of people who won't be comfortable at 30. So then we can think about other ways of providing comfort. So ceiling fans, desk fans, and equally natural ventilation. And there's lots of reasons why natural ventilation can be problematic in a city. This doesn't want to change. Sorry. There's lots of reasons why natural ventilation mightn't want to work in a city, largely down to noise, etc. But the air movement with natural ventilation is certainly going to help improve comfort levels within the space, particularly at higher temperatures. Other aspects is looking at biophilic design. So you can effectively distract people from their discomfort by providing plants, good daylighting, materials, etc. And we've seen that in our office, that people are more tolerant of higher temperatures. And that's my daylighting slide, so I'll just keep going. Other aspects are looking at landscaping around buildings, on buildings. So if you have landscaping in front of a facade, then you are providing biodiversity, you're providing contact with nature, so biophilia is projected into the building. But on a very practical level, you're reducing the heat build-up directly outside the building itself, so the air isn't preheated coming into the building. If it's in the case of roof, green roofs, etc., if you've got air handling units and chillers there, then they have a lower temperature to deal with. So less heat is drawn to the building, or the chillers are more efficient because they don't have as warm a temperature to reject heat into. And just the very basic things which we don't generally get right. So continuity of installation, removing thermal bridging, getting the infiltration levels to really low levels. So the passive house approach is very valid for net zero carbon buildings going forward, and it's been demonstrable as an effective way of reducing energy in buildings. And looking at concrete soffits is a good thing to do because that provides radiant cooling, and you can purge them at night time. But it's not as simple as that. An alternative is to use timber soffits, and Qian will talk about the embodied energy associated with timber. So that's a good way of reducing the embodied carbon, and also it's improving the biophilia of the space itself. But an issue on one particular project is that the cost of the timber slab is potentially 20 to 30% more than the concrete soffit. So if you took the increased budget associated with the timber, and you went for the concrete soffit and took that money saving, and you spent it somewhere else in the building, be it photovoltaics or improved controls or possibly embodied energy in another part of the building, would you get a greater reduction in carbon emissions for your buck? So the point is that you need to look at capital as a resource on a project and see how you can best get the maximum benefit in terms of carbon reduction associated with that resource. So we need to look at things in the round. I will pass you over to Qian. We'll take questions at the end, as Thomas mentioned earlier.
Thanks, Alan. Hi, my section, we're focusing on the materials and embodied carbon choices. of a building design. As Alan said, I'm focusing on the limit upfront carbon, and also I'll also expand on what's our take on whole life cycle consideration and what actions we could take to reduce that. And in terms of embodied carbon, it's not only to consider material use up to completion using this graph from the British Standard. It actually occurs in all the process of the building, including production and also in the in-use replacement and repair, and also towards the end, demolition and potentially recycling of the building material at the end. And also with UK grade or European grade is being decarbonized, the emission from electricity generation is getting less and less. So in long term, your embodied carbon is actually becoming a much bigger part. This is kind of demonstration graph. This is the green bit, the embodied carbon or the material carbon footprint. And over time, because the operational energy gets less and less carbon intensive, and your embodied carbon actually becomes a much bigger part. So it's kind of becoming increasingly important to consider that to eliminate that in your design. And in the UK and in Europe, we have RCS and RBA documentation in terms of how we deal and monitor and report embodied carbon. And also, we just done study and policy with Green Land Authority to set up the requirement for the planning applications. What process should they follow when they submit planning applications? And also, more recently, we've done a whole life carbon assessment tool and embodied carbon database for Hong Kong local government. This is for the purpose for them to record and promote low embodied carbon design and construction. And in terms of exam materials, from some more common material used in the building, say concrete, although by weight, almost 80% is aggregate and sand, the water, etc. But again, over 97% of your embodied carbon associated with cement, because cement is have a quite carbon intensive process to make. And to effectively reduce that, you can spend all your effort looking at recycled aggregate, but won't get you too much reduction in terms of embodied carbon, but it's more efficient to focus on using a reduced content of cement. This can be done by using cement replacement, or there's some more advanced technology called cement-free, or the earth-friendly concrete, which basically using a chemical, much smaller proportion of chemical and cement replacement instead of using normal Portland cement. But I said, for the limit, doesn't matter how good the material you use, but the best way to do it is always reduce the amount of material used. For example, in this building, we managed to convince the client to keep the building frame. And by doing that, then we actually reduce 25% of the building carbon footprint quite literally on day one. And also, if you look at this, keeping the fabric might be the only viable option in some scenarios if you want to do a true low carbon building. For example, this is two graphs we're comparing the refurbish scheme or building a new scheme. So in the situation when you build a new, demolish everything and build a new building, you might have a better energy efficient. In this case, the increased energy efficiency will mean the additional embodied carbon expenditure we paid back around year 35 or 34. But if the grid becomes decarbonized, that means the operational emission will not be that much different in terms of true emission, but they will different in terms of resource efficiency. But then if you purely look at emission in the end, the expenditure you spent at the beginning will never be paid back. So that kind of changes the perspective a little bit, or at least make you to think more carefully or holistically in terms of whole life cycle, and to consider what is true net zero and what is true low carbon. And also, as I said, you can, for example, steel, you can look at recycled steel, which is almost like a third as carbon footprint as normal, like a new steel. However, if you should also look at reduce the steel used or any material used in your building. For example, this one, the bracing on the facade is actually sized exact to the load. So it's quite easy to even maintain the aesthetic or the visual coherence of the facade. You just might have the same size. just getting the same size steel. But actually, in this case, the necessity gave way to the material efficiency. It's actually quite a good example to demonstrate this. And also in Cundall, we have embedded our embodied carbon database into our Revit model. So when our structural team or the design team doing design option studies, we could quite quickly get the quantity out and apply also high level but quick analysis of design option in terms of whole life carbon. Also, we can factor in the lifespan or potential modification to the building should it be, and this way we can design and identify what is the most suitable option in this particular building. As Alan said, there's no one solution fit for all. Maybe this solution is best for this one, but may not be applicable for another building for various reasons. Another sort of getting more popular choice now is a kit of part of design. Basically, by designing the building or construct the building into a kit of parts, that's reduced the wastage outside, reduce the construction process, and getting much higher quality build as well. And in our experience, this will roughly save about over 10% on embodied carbon. That's purely by reducing the wastage and also a much speedy construction process. And we talked about timber as a resource might cost more money to build, but potentially that offer a good environmental return. But again, we need to consider this holistically with operational emissions, and if this can justify itself in terms of embodied carbon. But also timber is a very good material should you wish to keep flexibility of your building. For example, this building, there are triple, double high space, and if the client wants to extend their building in the future to increase headcount, they quite easily do it. Extend the floor slabs up to the edge of the facade. This can be done with minimal interruption with the building. And also, just expanding on Alan's discussion on the facade, having a glass facade actually not only in terms of operational energy and daylight, but not a good solution, and also in terms of embodied carbon is quite high compared to a opaque facade, and also that require frequent maintenance, and potentially most likely you need to replace it at least once during the 60 years life cycle of the building. And also some other sort of less sort of a common area, but also deliver quite good saving is for example, the ductings. If you use a galvanized steel ductwork, it weighs about 50 kilograms per meter running, and the embodied carbon will be like over 150 kilograms of CO2 per meter running. And of course, if you can spend effort to find a better insulation, but that will give you about 5% reduction only. However, if you consider alternatives using insulation material or carbon material to remove the need of the steel duct, actually become much more efficient. That reduce over 70% or 60 or 68% of the embodied carbon. And also, of course, for the fit out, you could consider organic material, renewable material, and also things like recycled raised floor. That'd be quite easy to use. It's less shiny, but you're going to cover it up with flooring or carpet anyway. So that might be a quite good choice. Also, this will deliver a little bit of cost saving as well. And this is not a good example. If there's a previous scheme used a stone from 7 different Chinese granite quarries. But what we managed to do, we find 2 similar ones made in Portugal and Ireland, actually reduce the transportation emission by half while maintain a similar necessity. And what we did with the Hong Kong local government is we actually look at the material data, where they're getting their material from, where they import their materials, and where the material like to be made and to be used in Hong Kong. We actually created a embodied carbon database, and then the Hong Kong local government adopted for the contractors to submit embodied carbon during the construction, and for them to have to report the embodied carbon emission during construction, and then this is also for the contractors to actually record the lessons learned and also record innovations for them. This is for the purpose of roll it out to a bigger market and also to have a much robust database for Hong Kong. To summarize quite briefly for my section, we believe embodied carbon becoming a more significant issue for the industry. And there are changes in legislation, and also there are more data available, and there's also lots of new and innovative material we could adapt to consider for the building, which will deliver a direct saving and much also long-term benefit. Also by 2030, the UKGBC requesting 40% reduction of embodied carbon across from all the construction, which is quite challenging. And also if you found it actually true to be sustainable or zero carbon, we might need to consider even a more challenging target. So something we should start considering straight away. Okay, over to you, Madlen.
So you're on mute, Madlen?
Yeah, sorry, the good old mute. So my part is looking at reporting and offsetting, which is the last part of your building becoming net zero carbon. So I divided this in two parts. So first reporting and then offsetting. To report, so after you did all the reductions you've done, you could do anywhere possible in embodied emissions, but also emissions from operations. You then calculate your carbon footprint and would have to publicly disclose the carbon footprint to basically show everyone. So, sorry, it's not moving. To then show the actual emissions of your building. But with this reporting and with this public disclosure, there are a few more benefits coming along with this. So one is credibility, to show to your stakeholders, to your owners, tenants, that your net zero carbon strategy is actually credible and transparent. You can also compare your building with others, with the performance of others. Hopefully, public reporting will drive competition and innovation. And it can also be a good tool for owners, occupants, and investors to actually understand the performance of the building. And to do that, to both calculate the carbon footprint and also report, there are certain standards around. The most common one is probably the Greenhouse Gas Protocol. But there are also two ISO standards, 14064 and 14040, and the PRS 2060. And wherever you are in the world, there are certain sets of carbon neutral or net zero certifications you can actually obtain for your building. Here in Australia, we have the Climate Active scheme, but there's also the Carbon Trust and the Carbon Neutral Protocol and many more. And these are all based more or less on these standards mentioned there above. Now, what should go into your report? What should be included? Very important is relevance and completeness, so that that's all the emissions embodied, operational, not just energy, but also emissions from transport, from water, that all this is included within the correct boundary. Then there needs to be consistency throughout your reports, and this is maintained by following standards. So it's consistent from year to year, so you can compare the performance of your building from year to year on, but also against other buildings. Transparency, as I mentioned before, you would have to be, it has to be publicly reported, and accuracy, using as much real data as possible and doing as little assumptions as possible. This is a very, very simplified carbon footprint throughout the life of the building. This is only until year 20, but obviously would go further. So in year 1, just after the completion of the building, we have a part of the carbon footprint that comes from emissions from power usage, so operational energy, and then the other part, the gray bit, is the remaining emissions, including embodied carbon. And now the first part to go net zero is to really make sure you reduce these emissions from your operational energy through the measures Ellen outlined, but also through renewable power, through not having gas on site, or through purchasing green power. So that theoretically, ideally, would be already removed from your carbon footprint through these measures. These measures would also help to green the grid and to help the economy as a whole to become low carbon. And then the rest of the emissions, you would have to buy offsets for if you can't reduce them any further. So what is an offset? A carbon offset is an investment in an activity that reduces carbon dioxide emissions and is represented by carbon credits. So offsets basically is something you basically give money to someone else to reduce emissions somewhere else or to take carbon out of the atmosphere somewhere else. And a very rough categorization of offset types are technology-based and nature-based. So technology-based offsets would be, for example, renewable energies or energy efficiency measures. For example, there are projects that invest into steel plants to make the steel fabrication more efficient, or can also be the capture of other greenhouse gases like methane. And then there are nature-based offsets, offsets around forestation, but then also soil and wetland management or savanna management. So any offsets that improve the the environmental resources to be able to take in more carbon and absorb more carbon. And all these projects have to calculate how much carbon emissions they avoid or they deplete. And they also have to go through a verification process. And then you can basically buy a share of this carbon amount in form of a carbon credit. And one carbon credit is the equivalent of 1 ton of carbon emissions. So if your building footprint is 10,000 tons, you would have to buy 10,000 credits. But it's not only about carbon. When you buy offsets, they also include co-benefits. Very common benefits are empowerment or employment for minorities, for example, Aboriginal people here in Australia, or support for women and girls, or also general reduced pollution and improved health, or poverty reduction, and many more. And you will notice that these co-benefits, most of them already align with the Sustainable Development Goals. Because a lot of this carbon offsetting, a lot of the carbon projects are actually triggered by the IPCC and the Kyoto Protocol and the Paris Agreement. So all around the work of the UN. So if you report your activities and your organizations already against the SDGs, you can also align that with your offsets. So what are good offsets? An offset should always have a good QA procedure in place, which is ideally monitoring, verification, and reporting. Actually very similar to the reporting standard I outlined before. So transparency and accuracy and all this. And the offset units with the highest standards are usually seen as the gold standard. So there's a company called the Gold Standard where you can buy offsets from, but there are also verified carbon units, or here in Australia we have the Australian carbon credit units, which have very high standards. There are other offsets like CERs and RMUs, which are now a little controversial because they're actually renegotiated with the Paris Agreement and may become obsolete. So you should be a little careful when looking at those. Then the question, how much does it cost? This is when it goes into economics. So offsetting is, we see offsetting as a tool to actually put a price on carbon. And that price on carbon is then supposed to trigger a shift towards a low carbon economy. And as it is with economics, the prices are typically generated by demand and supply on markets, and offsets are also traded on global markets and global carbon emission trading schemes. But because carbon trading is relatively new, these markets are not perfect, and many are subsidized and slightly distorted. So this is a graph from the gold standard, and you can see these light blue boxes. They indicate the costs for 1 ton of carbon for different schemes of offsets. And you can see prices going down to even below $1.40. This is US dollar, by the way, which is very, very low. On the other hand, there are economists who actually say that these prices should be between $40 and $80 to really trigger change and really basically to make it hurt. and that you can't just buy yourself out of real action, and really give an incentive to do the passive design, to do renewable energy, and to do all this, and then do carbon offsetting really as a last resort. We usually recommend to not go too low with costs. We usually say that you should stay between 10 and 15 Australian dollars, or around 15 Australian dollars, or around 10 US dollars per offset, because then when it goes below, there are questions about credibility and that may be raised by your stakeholders as well. To wrap this up on a positive note, there is some evidence that we are moving towards a low carbon economy with a lot of schemes and commitments in place, and with the construction industry being responsible for about 1/3 of global carbon emissions, it's quite likely that there will also be more pressure on us as designers and architects and engineers from clients and from investors to actually build more net zero carbon buildings in the future. So offsetting is a very helpful mechanism to achieve net zero, but with the prices being relatively low at the moment, it can be quite controversial and leaving an impression of buying yourself out of real carbon reduction. And with this in mind, and also remembering the likely rise in carbon costs, offsetting should always be the last resort and should always only cover the bare minimum of emissions from a building after all effort has been put into avoiding these emissions in the first place. And this is through good passive design, intelligent systems, and a considered selection of materials. So to summarize, we heard Alan speaking about passive design, where the key areas were the orientation of the building and the glazing areas for daylight. Qian spoke about embodied carbon, but this is something becoming increasingly important with the decarbonization of the electricity grids, and it needs robust methodologies in place. And robust methodologies it also takes for offsetting. So offsetting should follow standards and should be comparable, and offsetting should always be only the last resort when no further reduction is possible. That's for me. I hand over to Audrey now for a Q&A session.
Thank you, Madlen. Thank you, everyone. Thank you, Alan, Qian, and Madlen for a thought-provoking presentation. So now we'll go over to questions. I mean, I'm conscious we're sort of running out of time, but so we'll answer as many questions as we can. So to start with, does the cost of carbon incorporate the cost of human displacement, coastal erosion, environmental inequality, etc.?
I think these costs I mentioned, the costs between $40 and $80 are likely to include that. The actual costs you can buy offsets for are likely to not include that. So we see offsets, as I said, down to $1.50. And what's recommended, or what was calculated by economists, should actually be up to $80. So there's still a bit work to do, and it got better in the recent years, but that's why it needs to be carefully assessed which carbon offsets you buy, and it should be the last resort.
Good, thank you. And another one, it seems like we should be trying to reuse and repurpose as much of the existing buildings as possible rather than new build? If that is a fair summary, is it realistic to get to the 50, 70 kilowatt meter square annum figure?
Well, the 50-70 figure or target, it's a very demanding target for an office building. Other buildings will find it easier, so residential potentially half that. So it very much depends on the type of building that you're looking at, and it also depends on the activity of the building. So a number doesn't really describe a building particularly well, because some buildings that are used 24 hours a day, 7 days a week, occupied 1 per 5 rather than 1 per 15, and it might have 40 watts a meter squared, a small power rather than 8. So a number in its own right doesn't describe that. Systems like neighbors will effectively provide a level playing field to compare buildings. So you're not looking at the actual energy consumption of the building in some ways, you're looking at a comparative. So it strips out the out of hours usage, etc., so you can compare the buildings properly. So it depends what you're trying to get to. I think you need both measures. I think you need to be able to see the actual consumption as well as the comparative. And to get to those numbers is very demanding. So as I said, you need to look at all aspects of energy consumption. You need to look at where energy is being wasted. Can you recycle it? Can you reduce it? And it's through all these various measures that we can get down to those numbers, but we can get down to those numbers.
Good. Thank you, Alan. So we've got quite a few coming through now. Another one, is the market the best solution for offsets? Why don't governments have the courage to tax carbon?
Yeah, that's a very economic question. So the problem with carbon taxes is that it's a set price, and it's once introduced, it can be very hard to raise a tax. It's always easier to lower them, but to raise them can be very controversial, very hard. And actually here in Australia, we have long discussions about carbon pricing. So governments chose to go for carbon offset markets to actually have the price being regulated freely by the market. But as I said before, it's still in its early days and it still needs to improve. This year, the Chinese offset trading scheme will come online, which has I don't know how many billion of offsets, which will probably quite change the market and quite drive prices up. So we will see also prices coming up in the next 10, 20 years.
Good. Thank you, Madlen. Do offsets account for the environmental damage and intensity of their construction, i.e. hydroelectric dam materials wise and environmentally damaging? Are there enough offsets to go around? Every industry, not just construction, is looking at using viable offsets.
So there are not enough offsets to offset every emission. Just to very simplify this, you can't plant enough trees to offset all emissions in the world. If you buy an offset, offset units mainly look at carbon, so they assess carbon. But I've seen projects, they publish their assessment reports, the auditor reports, and these auditor reports, they usually also look into other environmental issues, but the main focus is definitely on carbon. Another way, though, to assess environmental impacts from construction is a life cycle assessment. So when we talk about life cycle assessment, people usually tend to think it's just about carbon, but actually a life cycle assessment looks at many more impacts, which would also help the design team and the design process to reduce these impacts in the first place.
Good, thank you. So we'll just take a couple more. This one's for you, Alan. So you mentioned passive house being required for net zero. Is this a global solution or limited to certain climates?
Well, one of the key points about passive house is the quality of construction and delivering quality. And I think that's really important everywhere. And if you take a really hot climate, the poor performance of facades in terms of infiltration infiltration in particular, it has some very negative impacts within spaces because you get condensation occurring as the warm, moist air comes into the building, and it just condenses everywhere. So you get mold growth, which is particularly bad for your health, and it does quite a lot of damage. So keeping heat out can be just as important as keeping heat in. And I've always said something like a data center, you're trying to lose as much heat as possible. But there is an argument to be said that the heat in a data center could be trapped using passive house standards and reused. And we have done that in some of our data centers designs, where the heat from the data center has been taken and rejected to district heating systems. And low temperature district systems is the next generation of district heating, where you have a low temperature main and you use heat pumps to either draw heat from it or you push heat back into it. So you can then swap heat between different buildings. So I think passive house as a standard can be applied pretty much anywhere. I would watch out for the orientation thing, which I mentioned earlier, because for schools, they're trying to lose heat pretty much all the time. So trying to capture heat using glazing through the passive house standard might not always be the right standard, but certainly the envelope performance is spot on.
Good, thank you. And this one's for you, Qian. For embodied carbon calculations, how can we ensure the inputs reflect the specific and actual components used rather than generic industry standards? Most EPDs quote generic industry standard rates, which mean there is no incentive to source suppliers with better work practices.
That's a very good question. I think what we're saying is we're setting up standards for people to adhere to get consistency. And also we are seeing an increased number of material suppliers creating bespoke EPDs or the environmental product declarations that reflect their own specific material, which will help people to choose the correct information. Yeah, we agree using industry average data is good to set a baseline, but in terms of deliver the reduction or drive reduction, we are challenging the market a bit more now to get bespoke material data to reflect the exact emission of that product. This I think is happening. We're seeing lots of data coming out, but I think there's still a lot of work to do in this area.
Good, thank you. In order to tackle existing buildings, particularly listed ones, i.e. difficult to improve for performance, isn't the answer to simply purchase zero carbon energy? What can be done to increase the clean energy provision?
Well, listed buildings, existing buildings are certainly more difficult, but there's many things you can do, and the approach of looking at all the energy consumption of the building and seeing where it's going and how you do things with it. So, for example, a listed building could very easily have a canteen provision, which means that lots of heat is being pushed into the kitchen, and frequently you'll have cooling associated with that, where you just got the heat being dumped to outside. Well, why not take that heat, dump it into a thermal store, and that can be recycled to provide space heating in the space. So you're using what was waste heat to compensate for the fact that it may not be possible to upgrade the facades to the same level as you would to a non-listed building. So it needs to be looked at carefully, but even a listed building, there's lots of things you can do in terms of the infiltration improvement, which is not visible. That you may be able to use very thin double glazing in some instances. Other instances you can't. But infiltration by and far is usually the problem with older buildings, and you deal with that in the first instance. You've done a lot to improve the energy performance.
Good, thank you, Alan. So we've run out of time now, but if you have any further questions, please do feel free to send these through, and we'll be happy to get back to you via email. And to conclude this webinar, I just want to mention that we do have a range of global thought leadership webinar coming up, which is part of this series. So these are up on the screen at the moment. So you can register for those via our website, or you can also get in touch with us, and we'd be happy to provide you with further information on these. If you missed anything from today's webinar or would like to share it with anyone, please note that the recordings will be uploaded to our YouTube channel, so do watch out for that. Thank you very much, everyone, for attending.
Thank you all for attending.
Thank you.
Thank you.
Bye-bye.
See you at the next one.
Thank you. Bye-bye.